So, hi everyone, I am Sehrish. For people who don't know me, I work as a bioinformatics researcher at the University of Melbourne in Australia. Today, in my talk today, because I have a background in clinical genomics, I'm going to be talking about how do we use workflow in cancer genomics because I am part of a cancer research center. So this is who we are. The Collaborative Center for Genomic Cancer Medicine, where I work in, aims to bring together university leaders from different part or different groups. The idea is to improve the outcomes and quality of life for people affected by cancer, majorly. I personally am affiliated with this group highlighted in red square, where it's called Precision Oncology. As the name indicates, we focus on individual patients that are going through cancer and try and use genomics technologies to work out what might be causing it. A bit of basic intro. I have to do it because I am a researcher. Before I go into technical details, ever since the completion we saw in early 2000 of the Human Genome Project, omics has emerged. All of us know that it's a key focus for biomedical community specifically. And if we talk about clinical community, it has emerged as a right tool to use for understanding complex diseases such as cancer. So after that, we had seen there was a surge of bioinformatics methods because with data, you need methods to work. And that then as a result, you saw a massive production of data analysis techniques, and which later on resulted in move to virtualization of cloud technologies to handle this upsurge of methods and data. The question was, if you have a lot of methods, how do you pick from these methods and technologies? Even if you think about workflows, how do you pick which ones to go with? Personally, and in our teams and in our work, how do we assess different frameworks are they suitable? So if the method or the framework was published, do they have enough information to show that you can use it? So it's suitable. It has been validated, that it has been tested. If this is a tool that you want to use, was there any validation data available for the tool in terms of the purpose that it is trying to solve? Is it serving it? Maintenance is a very important one from bioinformatics side because you would like to know if it is well maintained. That is, as in research, it hasn't been abandoned after publication. How well supported the method is. So if you talk about community support, if you need support to fix the issues that you are going through, is there any support available? Which is obviously, you can judge that from the GitHub activity. So if you think about these factors, we are using CWL as our major language for workflows development because it's open source and community driven. That's the major kind of a motivation for us, which makes it really easy to access support and ask for advice in case of any issues. Also, if you think about reproducibility range, which we all talk about in workflows domain, the higher level of reproducibility for workflows we know is possible if you have a least dependence on your runtime or execution environment. CWL does allow you to achieve this, and that's where we have been using CWL. It also allows a greater digital reproducibility of the software environment, and that then enables for clinical setting greater reproducibility of results, because in clinical or genomic side of things, you can't produce a result without validating or reproducing it. Then comes the question of orchestration. How, if you have chosen a workflow language, how are you going to run it? Where are you going to run it? In our group, we use Illumina Connected Analytics, ICA. I'm not sure if you heard about it. It's Illumina cloud-based platform that allows workflow development and execution too. Why? What are some of the benefits of using this orchestration platform? Is it's cloud-based. You can use different workflow execution and tasks execution services to enable your analysis. You can use resources. As with cloud, you can specify what type of instances do you want to work with. Johan or Sean, one of these two people mentioned about streaming versus download. It's really important for genomics because genomics data is big. You can't wait at times for a task to start. You don't want the data to be downloaded before a task can start. So Illumina with their tools, which is Dragon, basically, they can start streaming the data. And as the data is being streamed in your instance, it can start processing it in bytes. So that's a positive thing, which means your data is processed pretty faster. Some of the other benefits are you can specify where do you want your data or outputs to be located. In S3, you can have your outputs in a different bucket as compared to your work directory. So Illumine ICA platform makes that everything very easy. I have small syntaxes here just to elaborate that the concepts look difficult, but when you start using and writing it, it's not that hard. At the end, after you have decided what workflow language and framework you want to use, I think, in my opinion, the bigger question is the scalability and portability of the analysis. With genomics, we know that by 2030, we are expecting that all over the world, we will have probably 250 million genomes sequenced. So if you have this sort of big data, where do you want, is it scalable? Is your solution scalable enough to tackle this kind of data? Hence, we have been working very closely with Illumina, our industry partners, to enable our analysis for genomics in the cloud. Not only analysis, but storage, which in clinical setting is very important because you need to have the data stored in your space for at least 30 years. You have to show that you are capable enough to store that data. I'm going to summarize this. I liked how Johan has similar kind of, I don't know if he kind of took it from this reference, but I love this study, which was published by Atkinson, this Venn diagram where he or the researchers talked about that data-driven workflows, they lie right at the intersection of question and the hypothesis that researchers ask or community ask and the teams. The answer to these questions are found by processing data and information, often through very complex algorithms and computing platforms. We can only achieve this if we allow joint efforts between domain experts, clinicians, data scientists, and most, I would say, very importantly, system engineers. Thank you so much. I hope I have finished in 5 minutes. I'm happy to talk about all this work later on during the discussion session.